Imagine if the sun suddenly became 2.5 times brighter overnight. Your morning coffee would literally boil in your cup, and you'd need industrial-grade sunglasses just to step outside. Well, that's essentially what just happened to one of the most famous stars in our night sky, and it has astronomers around the world completely freaking out. We're talking about Betelgeuse, the red giant that's been sitting in the constellation Orion for millions of years, and it just did something that's never been recorded in human history. The James Webb Space Telescope caught this massive star pulling off what can only be described as a cosmic light show. In just a few weeks, Betelgeuse increased its brightness by an absolutely staggering 250%. That's like switching from a regular light bulb to a floodlight in the blink of an eye. This isn't just unusual, it's potentially catastrophic, and it might be telling us that we're about to witness something that happens maybe once every few hundred years in our galaxy. You see, Betelgeuse isn't just any ordinary star. This thing is a monster. It's so massive that if you placed it where our sun is right now, it would swallow up Mercury, Venus, Earth, Mars, and probably the asteroid belt too. We're talking about a star that's 700 times bigger than our sun and over 10,000 times brighter. It's one of those red supergiant stars that are basically ticking time bombs, and they've been known to explode without warning. Located about 642 light-years away from Earth, Betelgeuse has been visible to the naked eye for as long as humans have been looking up at the sky. Ancient civilizations built entire mythologies around this star. The Egyptians associated it with the god Osiris, and countless cultures have seen it as a harbinger of change. Maybe they were onto something, because this star has been acting weird for years, and now it's doing something that has scientists questioning everything they thought they knew about stellar evolution. Red supergiants like Betelgeuse are basically stars having a midlife crisis, except instead of buying a sports car, they're preparing to explode with the force of 10 billion suns. These stars are in the final stages of their lives, and they're incredibly unstable. They puff up to enormous sizes, they fluctuate in brightness, and they're constantly throwing tantrums by ejecting massive amounts of material into space. But what Betelgeuse just did is on a completely different level. The James Webb Space Telescope, with its incredible infrared vision, was able to peer through the thick layers of dust and gas that surround Betelgeuse and get a clear look at what's happening. What it saw was mind-blowing. The star's surface was literally glowing brighter than anyone had ever seen before. This wasn't just a minor fluctuation. This was a dramatic surge that happened so fast it caught everyone off guard. Now, here's where things get really interesting. For years, astronomers have been predicting that Betelgeuse is going to explode in a supernova sometime within the next 100,000 years. That might sound like a long time, but in cosmic terms, that's like saying it could happen any second now. And this sudden brightening has some scientists wondering if that moment might be approaching faster than anyone expected. If Betelgeuse were to explode, it would be the most spectacular astronomical event in recorded human history. The explosion would be so bright that it would be visible during the day, outshining the full moon for weeks or even months. You could literally read a book by the light of a dying star that's over 600 light-years away. The explosion would create a new star in our sky, one that would be visible to every person on Earth regardless of light pollution or weather conditions. But don't worry, despite what some clickbait headlines might tell you, a Betelgeuse supernova wouldn't destroy life on Earth. The star is far enough away that we'd be safe from its radiation and high-energy particles. We'd basically get the most incredible light show in human history without any of the danger. It would be like having front-row seats to the universe's most spectacular fireworks display. The recent brightening of Betelgeuse has opened up several fascinating theories about what might be happening inside this massive star. One possibility is that the star experienced what scientists call a massive convective event. Think of it like a gigantic bubble of superhot gas rising from the core of the star to its surface. When this happens, it can cause dramatic changes in brightness as material gets ejected from the star's outer layers. These convective events are actually pretty common in supergiant stars, but they usually don't cause such dramatic changes in brightness. The fact that Betelgeuse's luminosity increased by 250% suggests that something much more significant might be happening. It's possible that the star is going through some kind of internal restructuring that's causing these massive energy releases. Another theory involves the star's magnetic field. While we don't fully understand the magnetic properties of red supergiants, recent studies suggest that these stars might have complex and dynamic magnetic fields that can influence their behavior. Changes in the magnetic field could alter how energy moves through the star, leading to rapid fluctuations in brightness. If this is what's happening to Betelgeuse, it could give us new insights into stellar magnetism. There's also the possibility that Betelgeuse has shed a massive amount of material in what scientists call a stellar eruption. Back in 2019, Betelgeuse went through a mysterious dimming event that had astronomers scratching their heads. Some scientists believe this was caused by a large cloud of dust that the star ejected, which then blocked some of its light. This recent brightening could be the aftermath of that event, with new material being expelled and illuminated by the star's intense light. The mass loss phenomenon in red supergiants is absolutely incredible. These stars are constantly throwing material into space at rates that would make your head spin. Betelgeuse loses mass equivalent to about 1 Earth every 6 years. That's an almost incomprehensible amount of matter being ejected into space on a regular basis. This mass loss is crucial in the final stages of a star's life because it can impact the star's structure and stability. If Betelgeuse is indeed losing mass at an accelerated pace, it could indicate that the star is approaching a critical point in its life cycle. When a red supergiant loses enough mass, it can trigger instabilities that lead to more dramatic events, potentially including a supernova explosion. The recent brightening could be a sign that these processes are accelerating. The James Webb Space Telescope has been absolutely crucial in studying this event. Its infrared capabilities allow it to see through the dust and gas that surround Betelgeuse, giving scientists a clearer view of what's actually happening at the star's surface. The telescope's sensitivity is so advanced that it can detect subtle changes in temperature and composition that would have been impossible to observe with older instruments. What makes this discovery even more exciting is that it's happening in real time. Usually, when we study stellar evolution, we're looking at processes that take millions or billions of years. But with Betelgeuse, we're seeing dramatic changes happening over weeks and months. This gives scientists an unprecedented opportunity to study the behavior of a massive star as it approaches the end of its life. The timing of this event is particularly significant because it's happening during an era of advanced space telescopes and sophisticated detection methods. If Betelgeuse had done this 100 years ago, we might have noticed that it got brighter, but we wouldn't have had the tools to study it in detail. Today, we have a fleet of telescopes both on Earth and in space that can monitor the star continuously and gather data that helps us understand what's happening. Ground-based observatories around the world are now pointed at Betelgeuse, taking measurements in different wavelengths of light. This multi-wavelength approach allows scientists to build a comprehensive picture of the star's behavior. They can track changes in temperature, monitor the ejection of material, and study the star's magnetic field variations. The implications of this discovery extend far beyond Betelgeuse itself. Red supergiants are common throughout the universe, and understanding how they behave in their final stages can help us predict the fate of other massive stars. This knowledge is crucial for understanding how elements are distributed throughout the galaxy and how stellar explosions contribute to the formation of new stars and planets. Supernovae are responsible for creating and dispersing many of the heavy elements that make up planets and life itself. The iron in your blood, the calcium in your bones, and the gold in your jewelry were all created in the heart of a massive star and scattered into space when that star exploded. By studying Betelgeuse, we're learning about the processes that create these elements and how they're distributed throughout the cosmos. The recent brightening has also highlighted the unpredictable nature of stellar evolution. Even with our advanced understanding of physics and stellar processes, stars like Betelgeuse can still surprise us. This unpredictability is part of what makes astronomy so exciting. Just when we think we understand how the universe works, it throws us a curveball that forces us to reconsider our assumptions. The star's behavior also raises questions about the timeline of stellar evolution. While we know that red supergiants eventually explode, predicting exactly when this will happen is incredibly difficult. The recent brightening could be a sign that Betelgeuse is approaching its final moments, or it could just be another phase in its chaotic life cycle. Red supergiants are notorious for their erratic behavior, and they can go through multiple episodes of instability before finally exploding. This uncertainty is both frustrating and thrilling for astronomers. On one hand, it makes it difficult to predict when we might witness a supernova. On the other hand, it means that every observation could potentially capture a historic moment in stellar evolution. The possibility that Betelgeuse could explode in our lifetime adds an element of excitement to astronomical observations. The study of Betelgeuse also involves understanding the complex physics of stellar interiors. At the core of the star, nuclear fusion reactions are converting lighter elements into heavier ones. As the star ages, these reactions become increasingly complex, involving the fusion of elements like carbon, oxygen, and silicon. Eventually, the star reaches a point where it's trying to fuse iron, but iron fusion actually absorbs energy rather than releasing it. When this happens, the star's core suddenly loses the energy source that has been supporting it against gravity. The core collapses in less than a second, creating temperatures and pressures so extreme that they trigger a massive explosion. This is what we call a supernova, and it's one of the most violent events in the universe. The recent brightening of Betelgeuse might be related to changes in these fusion processes. As the star depletes its fuel, the core contracts, causing the outer layers to respond dramatically to internal changes. This can result in large-scale ejections of material and temporary increases in brightness. In this sense, the recent brightening might be a precursor to more violent internal convulsions. The dust and gas clouds that surround Betelgeuse play a crucial role in how we observe the star. These materials can either dim or enhance the star's light depending on their composition and how they interact with the star's radiation. The 2019 dimming event was likely caused by a dust cloud that blocked some of the star's light. The recent brightening could be the result of that dust cloud dissipating or new material being ejected that's interacting with the star's light in a different way. Understanding these interactions is crucial for interpreting observations of not just Betelgeuse, but all red supergiants. The material ejected by these stars creates complex environments that can affect how we see them from Earth. By studying these effects in detail, astronomers can develop better models for predicting stellar behavior and understanding the life cycles of massive stars. The Betelgeuse brightening event has also captured the public's imagination in a way that few astronomical discoveries do. Unlike distant galaxies or exotic phenomena that require complex explanations, Betelgeuse is a star that people can actually see with their own eyes. This visibility makes the discovery more relatable and helps people connect with the science behind it. The star's association with the constellation Orion also adds to its cultural significance. Orion is one of the most recognizable constellations in the sky, visible from both hemispheres and prominent in winter skies. Many people have grown up learning to identify Orion, and Betelgeuse is one of its most distinctive features. The idea that this familiar star might be on the verge of a dramatic transformation adds an element of personal connection to the discovery. As we continue to monitor Betelgeuse, we're entering uncharted territory. Never before have we had such advanced tools to study a red supergiant during what might be its final stages. The data we're collecting could revolutionize our understanding of stellar evolution and provide insights that will benefit astronomy for generations to come. The story of Betelgeuse is far from over. Whether this recent brightening is a sign of an imminent supernova or just another episode in the star's chaotic life, it's providing us with invaluable data about one of the universe's most spectacular phenomena. As we watch and wait, we're reminded that the cosmos is full of surprises, and sometimes the most dramatic events happen right in our own cosmic neighborhood. The next few years will be crucial for understanding what's happening to Betelgeuse. If the star continues to show unusual behavior, it could indicate that we're witnessing the final stages of a red supergiant's life. If it returns to its normal patterns, we'll have learned valuable lessons about stellar variability and the complex processes that govern massive stars. Either way, we're living through a historic moment in astronomy, and the story of Betelgeuse will continue to unfold before our eyes.